When it comes to TLS, I'm trying to visit a website like Amazon.com or eBay.com, and they both have the secure HTTP. Now, before the communication starts, the moment you enter the URL in the URL box in your browser, you hit enter. What happens next is the domain name gets resolved and all those things. Then you get the handshake before the communication starts. So now when the communication starts, the TCP handshake goes first. But then the TCP by itself is not the secure protocol. So there needs to be the initial secure protocol like the SSL or the TLS that is being used for the client hello may not necessarily be the one that will be used throughout the communication. So sometimes the first one can be used or may be used to do the negotiation and just initiate communication, after which the subsequent communications will then be done with a more secure type of protocol. I'll give you an example. When it comes to TLS, I'm trying to visit a website like Amazon.com, or eBay.com. And they both have the secure HTTP, right, which is HTTPS. And you've already said correctly that we get the HTTPS are enabled through TLS or SSL, but in their case they use TLS, right? Now, before the communication starts, the moment you enter the URL in the URL box or the URL field in your browser, you hit enter, right? You tap on the enter key. What happens next is the domain name gets resolved and all those things. Then you get the handshake before the communication starts. So now when the communication starts, the TCP handshake goes first, right? The SYN ACK and ACK. But then the TCP by itself is not the secure protocol. So there needs to be the TLS handshake as well, but it goes immediately after the TCP. So the TCP connection needs to be initiated first to communicate, and then the security on top of that communication starts. So if you use a tool like Wireshark, right, you're going to see SYN ACK, which is the three-way TCP handshake first of all, after which you're going to see something like a client hello packet. If you tap on that packet, or you investigate that packet, or you follow the TCP stream, you're going to get more information about the packet and see what's inside. Then you see the TLS version that is being used to negotiate the communication. Now, bear in mind that the initial secure protocol like the SSL or the TLS that is being used for the client hello may not necessarily be the one that will be used throughout the communication. So sometimes the first one can be used or may be used to do the negotiation and just initiate communication, after which subsequent communications will then be done with a more secure type of protocol. I'll give you an example. You may see packets sometimes where after the TCP handshake, the TLS handshake is started with the client hello. If you investigate the client hello, you may see TLS version 1.0, which is old, right? It's archaic, it's ancient. So, but that may just be used for the initial negotiation. But if you investigate the packets further, you may then see something like TLS version 1.2 or 1.3. However, the point is the TLS handshake is done after the TCP handshake. Then you get something like hello client or client hello, and then you get the server hello. And then if you're using TLS 1.2, it's going to be long. Like you're going to get the client hello, you're going to get then the server response with server hello, after which the key negotiation or the key proposal is done by the client, and then communication then starts. But then with TLS version 1.3, it doesn't go through all those stages, which is a major difference between TLS version 1.2 and 1.3. So with TLS version 1.3, along with the client hello, the key negotiation is sent, or the encryption protocol is sent along with the hello, and the server also responds with that. Then the communication starts. So it's not as long, the process is not as long as TLS version 1.2, which is one of the things that makes TLS version 1.3 faster while still being secure, more than TLS version 1.2. Yeah.
Okay.
So TLS version 1.2 is out of date, but many companies still use TLS 1.2. TLS 1.2 would normally still be secure, but what makes it insecure is because of the backward compatibility it's got. So it's still compatible with many technologies to make it work, but those technologies that it's compatible with, that it needs to work, are the ones that are vulnerable, not the TLS protocol by itself.
Okay.
Does that make sense? So not the TLS version 1.2 by itself that is vulnerable. So TLS version 1.2 is normally secure, but because of the dependencies it's got on, some other technology, right? And yeah, some kind of backward compatibility issues and stuff like that. That's why those things around it are vulnerable. And when a part of a building or the part of a house, or a single part of a house is vulnerable, what does that mean for an attacker? They have an entry point. They just need a single entry point and that's it. So the same with TLS version 1.2, because there is even at least one vulnerable point that attackers can take in or that can be leveraged. Right, that makes TLS version 1.2 a bit insecure or unsecure. A website like Amazon is still using TLS version 1.2, right?
Yes, sir.
You would think they should be using version 1.3 by now, but you also need to remember, before you make any changes, before you make any decision, you need to do a risk assessment and also test the compatibility of whatever you're changing with your other components. How well does the new technology integrate with your existing components, especially the business critical components? So it's not just about there is a new update, we need to install it. But yes, there is a new update, it's got a patch, but does it work well with our existing systems? Because remember, enterprise systems are not the same as smaller organizations or smaller networks. With smaller networks, they are easier to manage. Not many components are coming together to work, but at an enterprise level, many components need to come together to work to give the customers the best experience, right?
Yes,
so Amazon, for example, being a customer-centric, customer-focused organization or company, you would expect them definitely to put the customer first. That also means their security. So if they still need to use TLS version 1.2, despite the vulnerabilities that are associated with TLS 1.2, what do you think they've put in place to make sure the customers are still safe?